Here is a short video covering everything in the GCSE higher tier to do with quadratics. A quadratic is an equation where the highest power is a squared. So it doesn't matter what comes after that, whether you've got x's and numbers or just x's. So long as the highest power is a squared, then it's a quadratic. And of course I could have this as 3x squared plus 4x. Doesn't matter that I've chosen for these all to have only one x squared in them, that's just coincidence. You will get a quadratic by multiplying out two brackets, and this is important because we're going to reverse this process as part of one of our methods to solving quadratics. So if I were to multiply out these two brackets using first, outside, inside, last, so first times first gives me x squared, outside times outside gives me 2x, inside times inside, 1x, 1 times 2, 2. If I just tidy that up by adding the 2x and the 1x, I get x squared plus 3x plus 2. Now you can do exactly the same for these other two, and what you notice at the end is you always get the same pattern. The number of x's is always what you would get if you took the two numbers inside the brackets and added them together. The number on the end of the equation is always what you would get if you took the two numbers inside the brackets and times them together. Now this gives us a clue as to how we're going to reverse this process. If I wanted to take this equation and put it into brackets, I know that my two brackets would need to have two numbers in it that added to give 3 and times to give 2. And there is only one pair that would actually work for that, x plus 1 times x plus 2. So here we are going to reverse the process and factorize, which means put into brackets, quadratics, which means equations that start with an x squared. So to factorize this one, I know I need two numbers that add to give 3 and times to give 2. So it must be x plus 2 and x plus 1. No other pair will work. It doesn't matter which way round you've got the two brackets. It could say x plus 1 times x plus 2, that's fine. When you're timesing things, the order doesn't matter. 2 times 3 is the same as 3 times 2. X squared plus 8x plus 12, so I need two numbers that add to give 8 and times to give 12. So there they are. Now you should stop the video for a moment and try the remaining examples on this page, and then restart it and look at the answers. Add to give 4, times to give minus 12, add to give minus 5, times to give plus 6. So that's factorising simple quadratics, and we'll probably stop there and do an exercise to practice that. There are special examples of simple quadratics. For example, I could have x squared minus 16, so here what I'm missing is the x term. Everything you've done previously has had x squareds, x's and a number. Here I only have x squareds and a number. So the simplest way to solve this is just to replace the x's. So this really is x squared plus no x's minus 16. And now I use exactly the same method as I used previously. I need two numbers that add up to give 0, and that tells me that they must be opposites. And they've got a times to give minus 16. So two opposites that times to give minus 16 is plus 4 and minus 4. Take a moment to try the second example. Stop the video and then restart. So x squared minus 15, that's x squared plus no x's, minus 25. So two numbers that add to give 0, so they must be opposites, times to give minus 25 must be x minus 5, x plus 5. Now the second variant is if it happens the other way around. Remember, everything we did initially had x squareds, x's and a number. The special case we've just done is if you've only got x squareds and numbers. So the remaining special case is if you've just got x squareds and x's. So if we just have x squareds and x's, we do the same as we did above and we replace the missing term. So x squareds, x's and our number was a 0 really. So now I know I need two numbers that add to give 4 and which times to give 0. Well, if two numbers times to give 0, one of them must be 0. That's the only way that that can happen. So I already know what that one must be, and if I know that they add to give 4, I know what the other one must be. So pause the video, try the next example. And there you go. Now, if the exam question says factorise the quadratic, then you can finish there. That's absolutely fine. If the exam question says solve the quadratic, then you have to go one step further. And what you have to do is you have to find the x value, or actually there will be two of them in most cases, x values, which make the equation work. And the whole point of what we've been doing up here in factorising it is that this allows us to solve the equations. So your answer to a solve question must begin with x equals. You're looking for a specific x value or two x values. And this method relies on the fact that if two things multiply together to give an answer of 0, one of them must be 0. There is no other way of doing that. So 5 times something is 0. The only possible number that could go in here is 0. If I tried 5 times 1/5, it wouldn't give me 0. If I tried 5 times minus 5, it wouldn't give me 0. So if two things multiply together to give me 0, I know that one of them or the other one must be 0. That's the only way it can happen. So when we factorise a bracket, when we factorise a quadratic, like we have done here, what we've got is one bracket times another bracket equals 0. So the only way that that can possibly happen is if the first bracket equals 0, in which case x equals minus 4, or the second bracket equals 0, in which case x equals minus 1. And what these two numbers actually mean, well, they are the two numbers, the only two numbers that you can put into this equation that would make it work. So if we just tried it quickly in our head with the simpler one, minus 1 squared is plus 1. 5 lots of minus 1 is minus 5. So we've got plus 1 and 4, which is 5, and minus 5, so it does work, it does make the equation equal 0. And what they mean for the shape of the graph of the equation is that these two numbers tell us the solutions to where this graph crosses the x-axis. So we know this graph will look something like this. Quadratics always give us U-shaped graphs. The proper name is a parabola, and a parabola has all sorts of useful and interesting physics and engineering properties that we will talk about. And you've found what's called the roots of the parabola, the places where it crosses the x-axis. Okay, so pause the video, try the next example. And it should have looked like this. So we needed two numbers that times together to give minus 9, and here are all my possibilities. So if you can't see the answer, you can work these questions systematically, and they've got to add together to give plus 8. So the pair which times is to give minus 9 and adds to give plus 8 is plus 9 and minus 1. So I've got this bracket times this bracket equals 0. The only way that's possible is if the first bracket equals 0 or the second bracket equals 0. And by solving these two little equations we know that x must be minus 9 or plus 1. So these are the two numbers that make that equation work. And in terms of the graph, these are the two numbers that represent the roots of the equation, the x-axis intercepts. Okay, pause the video again, try number 3. Okay. So this one was one of the special types of quadratics that we looked at on the previous page. The bit that's missing is the number on the end, so I replace that. So now I know I need two numbers that add together to give 7 and times together to give 0. And if those two numbers times to give 0, I know that one of them must be 0 and the other one must be 7. So I've got either the first bracket must be 0 or the second bracket must be 0, so that they can times together to give me 0. If x plus 0 is 0, then x is 0, which tells me that root of the graph. If x plus 7 is 0, then x is minus 7, which tells me that root of the graph. Pause the video, try the next example. Okay, so it's another special case. This time we're missing the x's, so we put them back in. So we've got x squared plus no x is minus 16. So we need two numbers that add together to give 0 and times together to give minus 16. So it's plus 4 and minus 4. So if these two brackets are going to times together to give 0, then either the first bracket must equal 0 or the second bracket must equal 0, which means that either x must be equal to minus 4 or plus 4, which means that my graph must look like that.